Harnessing the Power of Kubernetes, an in-depth guide to pod labels and selectors for streamlined cluster management. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Kubernetes, the open-source platform for automating deployment, scaling, and operations of application containers, offers various tools for managing resources within a cluster. Pod labels and selectors stand out as essential components for efficient cluster management. This podcast will delve into the intricacies of Kubernetes pod labels and selectors, exploring their definition, purpose, and practical applications. Understanding Kubernetes pod labels. Definition and purpose of labels. Labels in Kubernetes are key value pairs assigned to objects such as pods, services, and nodes. These labels serve as metadata, providing a way to organize and categorize objects within the Kubernetes ecosystem. Unlike names and UIDs, which must be unique, labels can be shared across multiple objects, enabling flexible grouping and selection. How labels function as metadata for Kubernetes objects. Labels act as identifiers that Kubernetes uses to manage and filter resources. By assigning specific labels to objects, you can create logical groups that can be easily managed and manipulated. For example, you might label all pods running a particular microservice with app equals frontend, allowing you to target these pods with specific actions or configurations. Implementing labels in Kubernetes. Adding labels to pods, declarative and imperative methods. Labels can be added to Kubernetes objects using both declarative and imperative methods. Declarative method. Labels can be included in the YAML configuration file to define a pod. For example, API version, v1. Kind, pod. Metadata. Name, example pod. Labels. App, frontend. Environment, production. Spec, containers. Name, nginx. Image, nginx. Applying this configuration will create a pod with the specified labels. Imperative method. Labels can also be added or modified directly from the command line using kubectl. Kubectl label pod example pod app equals frontend environment equals production. Modifying and overwriting labels, practical examples. Labels can be modified or overwritten easily using kubectl. For instance, to update the environment label. Kubectl label pod example pod environment equals staging overwrite. This command updates the environment label from production to staging. Labels can also be removed using the kubectl label command with a at the end of the label name. Kubectl label pod example pod environment. Exploring Kubernetes selectors. Introduction to selectors and their role in resource filtering. In Kubernetes, selectors allow you to filter resources based on label values. They are crucial in identifying and grouping specific resources, enabling fine-grained control over your Kubernetes objects. Types of selectors: equality-based and set-based selectors. Equality-based selectors. These selectors filter resources based on exact matches between labels and their values. For example, to select all pods with the label app equals frontend, you would use kubectl get pods l app equals frontend. Set-based selectors. These selectors allow more complex filtering using operators like in, noten, and exists. For example, to select all pods where the environment label is either production or staging. Kubectl get pods l environment in, production, staging. Practical application of labels and selectors. Listing existing labels and applying new ones to pods. You can list all labels associated with a specific pod using the following command. Kubectl get pod example pod show labels. To add a new label to an existing pod. Kubectl label pod example pod new label equals value. Overwriting and deleting labels, command line demonstrations. To overwrite a label, use the overwrite flag shown earlier. To delete a label, kubectl label pod example pod old label. This command removes the old label from the example pod, filtering pods with selectors. Selectors allow you to target specific pods for operations. For example, to scale down all pods labeled with app equals frontend, you could use kubectl scale deployment frontend replicas equals 0l app equals frontend. Advanced filtering techniques with logical operators. Kubernetes selectors support advanced filtering with logical operators. For instance, to filter pods that are in production but not running a particular version. Kubectl get pods L environment equals production, version Noten, v2.0. This command retrieves all production pods that are not running version v2.0. Summary and next steps in Kubernetes mastery. In this podcast, we explored the fundamental concepts of Kubernetes pod labels and selectors. We covered how to implement and manage labels, the role of selectors in filtering resources, and practical examples of their application. Understanding these concepts is vital for efficient Kubernetes cluster management. As you continue mastering Kubernetes, future topics might include advanced network policies, managing stateful applications, and implementing custom controllers for automated resource management. By mastering pod labels and selectors, you're well on your way to becoming a Kubernetes expert. Stay tuned for more advanced topics to enhance your skills and understanding of this powerful platform. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.